lattice energy or lattice enthalpy. I'm sure you must have come across this term. What does this mean? Lattice enthalpy or lattice energy is the energy released when Na plus Cl minus come closer to form NaCl. So that is what I have given a small example to you to make you understand what lattice energy. I'll repeat it again. Na plus Cl minus come close to each other to form NaCl. In this process, stability is increasing, so energy is decreasing. So the difference of energy is being released out of the system. This released energy when NaCl formation occurs is known as lattice enthalpy or lattice energy. Similarly, when you have to separate NaCl into Na plus and Cl minus, you have to give that amount of energy. So you can say lattice energy in terms of NaCl formation as well in terms of NaCl separation. So if we separate Na plus and Cl minus from NaCl, that the amount of energy you will need is known as lattice enthalpy or lattice energy. So what does this depend on? As I told you, the energy required to separate, the more is the attraction. The more is the attraction between Na plus and Cl minus or any ionic compound. For that matter, the attraction between cation and anion, if it is more, the lattice energy value will be more. If attraction is less, the value of lattice energy will be less. So where does attraction comes from? Just give it a thought. If charges are more, if charges are more, that means attraction will be strong. So attraction is strong, so energy required to remove ions will be more. So first point that you need to remember is that lattice energy or lattice enthalpy. See, in chemistry, for energy we use the term enthalpy. Alright. So lattice enthalpy is directly proportional to charge. Lattice enthalpy or lattice energy is directly proportional to charge and inversely proportional to size. So which is dominating? If you have to check out one factor, always charge is the dominating factor. If charges are less or more, just remember that the ionic compound where more charges are there, lattice enthalpy will be more. For example, if we take up, let's say, NaCl, MgCl2, AlCl3, and you are asked where lattice energy value is more. I'm pretty sure that you will say that in NaCl the charge is Na plus Cl minus, in MgCl2 the charge on Mg is plus 2, and here charge is plus 3. So let's check out, because negative ion has the same charge, Cl minus, Cl minus, Cl minus. So we are not comparing on the thing that has the same value. Whenever you have comparison, always remember you have to check out the point of difference. So here the point of difference is the charge on cations. So what is the charge over here? Plus 1, plus 2, plus 3. So more the charge, more is lattice enthalpy. So lattice enthalpy value is like this. AlCl3 has more lattice enthalpy than MgCl2, MgCl2 has more lattice enthalpy than NaCl. Alright. Similarly, if you have been given from an example is where size is differing, NaF, alright, and then Kf and RBF. What do you think? Lattice enthalpy value, because charges are same, plus 1, plus 1, plus 1. Now size of Rb plus is more than Na plus. So more the size, less the lattice enthalpy. So in this case, lattice enthalpy of NaF is more than Kf, Kf is more than RBF. So directly proportional to charge and inversely proportional to size. That is how lattice enthalpy is compared whenever we have certain examples. Alright. And what else do we have? We have a Born-Haber cycle that is used for calculation of lattice enthalpy. This Born-Haber cycle tells us all the energy changes happening during an ionic bond formation. So if you check out this, then you will understand how much is happening in a ionic compound formation. See, if NaCl has to form, first what will happen? In nature you have in solid form. In nature, you will have Na in solid form. From solid Na to it goes to gaseous Na. This process is sublimation. It requires energy. So this is an endothermic process. It will absorb energy. Next, from Na you have to remove one electron. Again, removal of electron or ionization is an endothermic process. Energy we need to give over here. So Na plus is formed. Now, in the formation of Cl minus, for NaCl formation you will need Na plus and Cl minus, right? So Cl2 is here, half of Cl2. So half mole of dissociation energy is required. Half mole is taken, so half of bond dissociation enthalpy, because enthalpy is taken per mole. So we have taken half mole, so half of bond dissociation enthalpy is required over here. So half Cl2 gives Cl. Now what will happen is Cl will gain electron. Cl is gaining electron. This process is again exothermic. From Cl to Cl minus formation, it is an exothermic process, and the energy associated is known as electron affinity. Alright, and when Na plus and Cl minus we have, then this Na plus and Cl minus get attracted to form a lattice. What is a lattice? Lattice is a specific arrangement of cation and anion in the formation of a ionic crystal. For example, if you check out NaCl crystal, what you see? You see a arrangement where Na plus Cl minus are arranged in a lattice or a pattern. This pattern is known as lattice. I have given you a small glimpse. How does it look like? The lattice in NaCl looks like this. Alright. So have you given it a thought while you are having some dish of your choice? Have you given it a thought that the salt that is being used in the pizza that you are having or the burger you are having, the salt is like this, which has Na plus Cl minus Na plus Cl minus. I don't think you must have given it a thought. And the formation of NaCl, the salt we are having, involves so many steps. I'm pretty sure you must have never thought of it. So never underestimate the formation of ionic compounds. If you know this, then you know how important our nature, how important things our nature is giving to us. So that is what chemistry is all about. It tells you how things are formed. You understand, you value them more. All right. So that is it for now.